Now, we have an equation to solve. But this is not your regular flat equation. This equation is given in algebraic fractions. Now, quite a few students would take different approaches to this problem. One approach that students might take is that they might want to eliminate the denominators immediately. You will have another student who would want to take advantage of the fact that all we have is a numerator of 1, and if we can reciprocate that fraction, then we will not just have x over 1, but x over 1 would just be x. It would be x divided by 1. Any number divided by 1 is that same number. Or expression or term divided by 1 will be that same term or expression. So that's an approach that students might want to take. Now, in order to do the reciprocal, students know that if we just take the reciprocal right here, right off the bat, then we might find ourselves in trouble, because what we really need in order that we can do the reciprocal is to get the fractions on either side of the equation. So we have two equal fractions, so that when we do the reciprocal of both fractions, then they will still be equal. So let me repeat that. If we have two equal fractions and we do the reciprocal of those two fractions, then the two reciprocals will also be equal. And that is a very important bit of knowledge in mathematics that we will do well to take advantage of. You know, that can really greatly simplify our work. But let us see on this occasion what approach Richard James Mathematics Resources will take. The first step is to eliminate that more complex fraction from the left-hand side by subtraction. So our first move will be to eliminate that more cumbersome fraction from the left-hand side, and we will do that by subtraction. Well, it might be a little bit baffling at the moment, the question, why would we eliminate the more cumbersome fraction rather than the simpler one? Well, let's see. So we are going to eliminate that more complex fraction from the left-hand side by substitution. And we are, of course, including the intermediate steps, you know, the more minute steps, the finer details. Yes, we are including those on the side. So we are just doing that on the side. And then we have our main expression here that we are actually solving. So solve the main expression. Any microscopic moves, we have them on that side. So our first move is to eliminate that cumbersome fraction by subtraction. So let us go straight ahead. There we go. While doing that, we cannot just subtract something from one side of the equation. We will have to do that on the other side also. There we have the fraction being subtracted from both sides of the equation. So our intention is to eliminate this fraction from the left-hand side. We will do that by subtraction. We have to keep the equation balanced by doing the same on the other side. What will be the result? That will be the result. So right there, what we have is 0 minus 3 over 7x minus 1, which will give us the negative of 3 over 7x minus 1. And if you paid attention to the audiovisual on negating fractions, you'll see exactly what we are going into right at this moment. That if we need to negate this fraction, we have a positive term followed by a negative term, and you know exactly what you are going to do. The mechanics will be that the terms will exchange places. Reason being that we are multiplying negative by positive, which will give us negative. Then we have negative multiplied by negative, which will give us positive. The positive term will follow the negative, and appropriately, we should put the positive term first. So when this is multiplied negative by negative, we will have a positive 1, which will lead out in the denominator. So the fraction may be negated by switching the terms in the denominator around. And it is not just merely switching them around, but we know that negative times negative is positive, and negative times positive is negative, and we are just choosing to put the positive 1 at the front and the negative 1 at the back, as would have been evident from the audiovisual on negating fractions. There we go. So that is what we have now. And we know that if we have two fractions that are equal, their reciprocals are also equal. But let us see if that is what we will do. If two fractions are equal and we reciprocate them, then they are still equal. So let us do that. Correct. So as a matter of fact, we are just taking advantage of that. Now we have x over 1 is equal to x, as I said before, because we are taking advantage of the fact that this expression that we have right here, this term, is ready to be reciprocated, because when we reciprocate it, the result will just be x. So based on that, we will have x here, and that is just going to be equal to that, which we have in our intermediate step that we promised that we would have included in the audiovisual. Now we are going straight ahead to eliminate the denominator. And what do? Let's see if we have a caption for that. No, not yet. But we have actually the mechanics right on that right-hand side. So we will go straight ahead from here to eliminate the denominator that we have there. And we say that colloquially that we are flattening the equation. So let us flatten the equation. All that we need to do, eliminate this 3 that we are dividing by multiplying by 3. And do not forget that we need to balance the equation by doing the same on the other side. So on the left-hand side, we have 3x. 3 times x is 3x. On the right-hand side, we eliminate those 3's. As a matter of fact, our intention was to eliminate the 3 from the denominator, and that we have done. So let us go back to our regular programming. We have 3x is equal to 1 minus 7x. And anyone's guess is as good as mine that we need to have those x's together. And I imagine that the sensible thing to do is to accumulate those terms containing x on the left-hand side, because we have a negative term here, so it would make a lot of sense to add in order that the entire equation will contain only positive terms. So add the 7x in order to eliminate this negative 7x from the right-hand side. And of course, do the same thing on the left. So we intend to eliminate that negative 7x from the right-hand side. And we will do that by adding 7x. Balance the equation by adding 7x on the left-hand side also. So very quickly, we put these together. 3x plus 7x will be 10x. Of course, your negative 7x would have been eliminated, and the result on that right-hand side is just 1. So 10x is equal to 1. And all we need to do now is to eliminate that 10 that is multiplying that x. Or we may say is accompanying that x by multiplication. So eliminate that 10 that is accompanying that x by multiplication by dividing by 10. And do the same on the other side in order to keep the equation balanced. And we have no doubt that our answer will turn out to be, let me see if we did anything there. No, not quite. So, right, we didn't do it, but here we see that the 10 is being divided by 10, which will cause the 10 to be eliminated there, and maintaining the 10 that we are dividing by on the right hand side, we have the right hand side is equal to 1/10, while the 10 is eliminated from the left hand side. So consequently, x is equal to 1/10. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.